Okay, so we are asked to investigate this function and figure out where the discontinuities are. So let's just recall what the types of discontinuities are. So we have jumps, removable discontinuities, and infinite discontinuities. Okay, so what does this function look like? Well, right off the bat, we know that x can be 0, right? This function is not defined at x equals 0 because, 1 divided by 0 is not defined. So we have, let's just draw this out, right? So at x equals 0, this function is not defined. But what happens, so we should look at this function and try to figure out what happens to this function as we get closer and closer to 0, right? So any numbers far, so what happens as x approaches infinity, right? Let's say, so if you want to plot this thing out, so there are a couple of conditions we should look at, right? So 1, as x approaches infinity from both sides, to the positive and to the left and the right, and then again as x approaches 0 from the right and from the left. Okay, so let's look at this. Let's look at the behavior of f of x as x approaches infinity to the right. So it goes off into infinity to the right, right? So as this x value gets bigger and bigger and bigger and bigger, what happens to the value of f of x? Well, as x gets larger and larger and larger, 1,000, 5,000, 10,000, 30,000, 100,000, a million, this value gets closer and closer to 0, right? 1 divided by a huge number is a tiny, tiny, tiny number. So as we run off towards x, so let's just label these, right? As we run off towards x, this function gets closer and closer and closer and closer and closer to 0, right? So that's fine. What about negative infinity? As we go to x in the negative direction, same thing, right? Because we get closer and closer. It's a negative number, but we get closer and closer and closer and closer to 0. So in this case, we get closer to 0, but the value of f of x is positive. But in the x negative direction, we get closer to 0 as well. But in this case, the value is negative, a tiny negative number, right? So we get smaller and smaller negative numbers. So now I'm leaving this part, like I'm not doing anything close to 0 because I want to investigate it separately, right? Okay, so now what's happening? Let's see what happens as we get closer to 0 from the right, right? So as we get closer to 0 from the right, as we get closer to 0 from the right, we're basically dividing 1 by a smaller and smaller number, right? So let's just say f of x over here, right? Let's just say x, and just for the sake of illustration, x and f of x, okay? So we're getting a tinier and tinier positive number. So let's say, 0.001, 0.0001, 0.00001, right? And if we put these numbers into this function and divide all of them by, divide 1, for example, 1 by 0.001 is 1,000, right? The 1 divided by 0.0001 is 10,000, right? And then this is 100,000, right? So 1 divided by, just checking, making sure my math is right. Yeah, 100,000. So we can see as we get closer and closer to 0, this number shoots off, gets bigger and bigger and bigger, and this will continue, right? It'll get huge and huge, and we can see that as we get closer to 0, the value of the function starts shooting up and goes like that, right? Okay, and the same thing happens, exact same thing happens if we did this thing in the negative direction. This will be, if we divide by negative number, this will be a huge negative number, right? So similarly, this function could do something like that, right? And indeed, this is what the 1 over x function looks like. It's not defined at x equals 0, and it behaves like this as x gets as you go in the either direction of x. Okay. So what we have here to answer our question is that there is a infinite um, discontinuity at x equals 0, right? So this function is yeah, okay. So infinite discontinuity okay.